Sundaresh SS, quote a paragraph from an advanced textbook of maths using the words asymptote and intercept. Meta AI, here's a paragraph from an advanced calculus textbook. When analyzing the behavior of rational functions, it's crucial to identify key features such as vertical asymptotes, horizontal asymptotes, and intercepts. Vertical asymptotes occur where the denominator equals 0, causing the function to approach infinity or negative infinity. Horizontal asymptotes, on the other hand, describe the function's behavior as x approaches infinity or negative infinity. The x-intercept is found by setting the numerator equal to 0 and solving for x, while the y-intercept is determined by evaluating the function at x equals 0. Understanding these characteristics enables us to sketch the graph of the rational function and analyze its properties. Would you like more information on rational functions or asymptotes? Sundaresh SS, now, define each word which relates to the maths jargon in the above paragraph using simple English as found in a dictionary. Meta AI, here are definitions for the math-related terms. Math terms. 1. Asymptote. A line that a curve approaches but never touches. 2. Intercept. A point where a line or curve crosses an axis. 3. Rational function. A function that is the ratio of two polynomials. 4. Denominator. The bottom part of a fraction. 5. Numerator. The top part of a fraction. 6. X-axis. The horizontal axis in a coordinate system. 7. Y-axis. The vertical axis in a coordinate system. 8. Infinity. A concept representing a quantity that has no end or limit. Let me know if you'd like further clarification. Sundaresh SS, now, insert the meanings into the paragraph and rewrite it. Meta AI, here's the rewritten paragraph with the math terms defined. When analyzing the behavior of rational functions, functions that are the ratio of two polynomials, it's crucial to identify key features such as vertical asymptotes, lines that a curve approaches but never touches. Horizontal asymptotes, lines that a curve approaches but never touches, describing the function's behavior as x approaches a quantity that has no end or limit, and intercepts, points where a line or curve crosses an axis. Vertical asymptotes occur where the denominator, the bottom part of a fraction, equals 0, causing the function to approach a quantity that has no end or limit or negative infinity. Horizontal asymptotes describe the function's behavior as x approaches a quantity that has no end or limit or negative infinity. The x-intercept, point where a line or curve crosses the horizontal axis, is found by setting the numerator, the top part of a fraction, equal to 0 and solving for x, while the y-intercept, point where a line or curve crosses the vertical axis, is determined by evaluating the function at x equals 0. Understanding these characteristics enables us to sketch the graph of the rational function and analyze its properties. Let me know if you'd like further clarification. Sundaresh SS, can this method be used to study the whole of the textbook of advanced maths from which the paragraph was taken? Meta AI, while defining math terms in simple language can be helpful for understanding specific concepts, it might not be sufficient to study the entire textbook on its own. Here's why. Limitations. 1. Depth of understanding. Advanced math concepts often require more than just definitions. They involve complex relationships, proofs, and applications that need to be explored in depth. 2. Contextual understanding. Math concepts are often interconnected, and understanding one concept relies on grasping others. Simply defining terms might not provide enough context. 3. Practice and application. Math requires practice and application to reinforce understanding. Defining terms alone might not provide enough opportunities for practice. Complementary approach. However, using definitions as a complementary approach can be beneficial. 1. Building foundation. Defining terms can help build a strong foundation in math by clarifying key concepts. 2. Review and reference. Having a reference point for definitions can be helpful during review or when encountering unfamiliar terms. 3. Supplementary resource. Using definitions as a supplementary resource can aid in understanding complex concepts, especially when combined with other study materials like examples, proofs, and practice problems. Recommended approach. To study the entire textbook effectively. 1. Combine definitions with examples. Use definitions in conjunction with examples, proofs, and practice problems to deepen understanding. 2. Work through problems. Practice problems and exercises help reinforce understanding and build problem-solving skills. 3. Use multiple resources. Supplement textbook material with online resources, video lectures, or study groups to gain a more comprehensive understanding. 4. Review regularly. Regular review helps solidify knowledge and prevent forgetting. By combining these approaches, you can develop a deeper understanding of advanced math concepts and effectively study the entire textbook.